Example number 9, using the intermediate value theorem. Show that the function f of x equals x cubed minus 5x squared plus 3x plus 6 has at least two real zeros between x equals 1 and x equals 4. So as a start, we're going to evaluate f of x at the integer values from 1 and 4. So we're going to choose 1, 2, 3, and 4. And then we're going to create a table. So if we plug in x equals 1, plug it into the function, we get 1 cubed minus 5 times 1 squared plus 3 times 1 plus 6. That gives us a value of 5. So when the input is 1, the output is 5. When we plug in the value of 2 into the function, we get 2 cubed minus 5 times 2 squared plus 3 times 2 plus 6, and that gives us 0. So when the input is 2, the output is 0. If we plug in the value of 3, we get f of 3, which is equal to 3 cubed minus 5 times 3 squared plus 3 times 3 plus 6 gives us an output of negative 3. So when the input is 3, the output is negative 3. Plug in the value of 4, f of 4, so 4 cubed minus 5 times 4 squared plus 3 times 4 plus 6 gives us an output of 2. So in step number 2, we can see that 1, 0 occurs at x equals 2 because it doesn't have a 0 as an output here. So let's take a look at this though. So we know that between 1 and 3, it's going to go from a positive to a negative because 0 is neither positive nor negative. So between the values of 1 and 3, we have a 0. And then from positive 3 to 4, we can see that it goes from negative 3 to a value of 2. So there's a 0 that's going to exist over here. So again, we see that 1, 0 occurs at x equals 2. And also, since f of 3 is negative and f of 4 is positive, by the intermediate value theorem, there must be at least one real 0 between 3 and 4. We have shown that there are at least two real zeros between x equals 1 and x equals 4. Now we can also see on the graph of the function in figure 18 that there are two real zeros between x equals 1 and x equals 4. So if we look at the interval between x equals 1 and x equals 3, we can see that f of 1 has an output of 5, which is positive, and we can see that f of 3 is going to have a negative, and so that means here we have a real 0 of 2. And then if we look at the interval between 3 and 4, okay, f of 3 has a negative 3 output, f of 4 has a 2 output, which means there's another x-intercept that's close to 4 but not at 4. So that means we can see that we have two zeros here.